Hello, so this is a demonstration of my project. We have retrieved the data using the call request. So if we were to take a look, these are the two files we have here. We put it under Avro schemas. The schemas are loaded. Then we have this Docker Compose. Compose was available on the internet. So one important part about this configuration that I changed is volumes. So basically this means that inside of the KSQL data gen, we basically copied all these Avro schemas into this folder over there. What we're going to do now is we're going to Docker Compose up detached. Okay, nice. So the KSQLdb is running now, so we're just gonna make a test. Basically, I'm gonna copy and paste these data gen items listed in the report. So this is the activity stream. And we create the tables. Okay, let's try this out. Okay, it's streaming in. Okay, then we're gonna do a join. That will be basically it for the demonstration. Let's just write it out ourselves. Changes, and it's basically going to have nice enriched data. Yeah. Okay, so what we have done is we have basically did a join on the customer and the activity. What we can actually do is to show how we can create queries to analyze this real world data. So some things to note are maybe the number of activities that are happening, and we can make something like this where we create a stream where the activity is not new account. We're excluding new account because we want to track the usage of the service. Maybe if the usage of your service is high, then there is lesser churn rate. Okay, so we're going to create this query. This is how it looks. There's activity count and there's the customer ID. It will be grouped accordingly. Next one is inactivity. So almost the same thing, but this time we are filtering to those who have one activity, but there is no zero activity. Reason is it's an event driven stream. If there is no event, then it won't show up. Next, propensity to churn. That's basically the main property that can define churning. We created this. We set a filter to make sure that the propensity churn is more than 0.7, and we notice something interesting here. We can see a tombstone, which means that the average churn actually dropped below 0.7, but it can't delete because events are immutable. Next one is basically multiple IP addresses. In one day, we have a list of IP addresses. We filter more than or equal to 3 IP addresses for customer ID, then they will be flagged out. Why this is a use case is because if the user is using multiple IP addresses, it may indicate some sort of account sharing or some suspicious activity that can be associated with churn. We use collection and array length because count district is not supported in KSQL. Okay, finally, we have this very big implicit query setting many different thresholds to determine whether someone is churning. So we are considering a lot of factors: their total activity, propensity to churn, their distinct IP address count. So this is how it looks like. So we see a lot of tombstones reference to previous customer IDs. It's very actionable. You see these customer IDs, you can flag them out. Maybe you can give them a retention offer. Okay, that's about it. Thanks.